So now we're going to talk about the derivatives of inverse trig functions. So we're going to focus on one in particular, one function. So the y equals sine x. If I wanted to find the inverse of this function, I know that to find the inverse, all I need to do is switch the x and the y. So I would get that x is equal to sine y. Now, if I wanted to find the derivative of this inverse function, we are going to first just look at this triangle that's here. So here's a right triangle. To kind of illustrate this a little bit better, we're going to use this. So if I have x equals sine y, let's call this angle y here. So sine of y, if you remember from geometry, sine is going to be your opposite side of your triangle over your hypotenuse. So opposite over hypotenuse. So the sine of y is equal to x. So it's really like x over 1. So it's going to be the opposite is going to be x, and then the hypotenuse is going to be 1. Okay, we're going to use this in a minute. And then I have this third side. We'll worry about that in a minute. So if I wanted to take the derivative, d over dx, of x equals sine y, the derivative of x is going to be 1. And then the derivative of sine y is going to be cosine y dy over dx. So we're still using the chain rule here because the outer function is sine and the inner function is y. And because the derivative of y is dy over dx, we have this. Okay, so if I wanted to get dy over dx by itself, I have to divide cosine y on both sides. So dy over dx equals 1 over cosine y. So to figure out what cosine y is, we need to look at our triangle. Right? So we said that the opposite side is x, the hypotenuse is 1. So there's this third side, right? I'm just going to call that like side B or whatever. I can find that by doing the Pythagorean theorem from my triangle. So I know that using Pythagorean theorem that I have x squared, so one side squared plus the other side squared, is equal to the hypotenuse squared, which is going to be 1. To solve for b squared, I'm going to subtract x squared, so b squared equals 1 minus x squared. And then I'm going to take the square root to get b by itself. So b is equal to the square root of 1 minus x squared. So that means that this side that we called b, I'm just going to get rid of that for 1 second, that is going to be the square root of 1 minus x squared. So when I'm looking at my derivative over here where I have 1 over cosine y, well, here is angle y. The cosine, using the triangle, is adjacent over hypotenuse. So the adjacent is going to be the square root of 1 minus x squared, and the hypotenuse is 1. So we have 1 over the cosine, which is going to be square root of 1 minus x squared over 1, which is just that. So the derivative of the inverse function of sine is equal to this. Okay, so for all of the trig functions, you can find the derivative of the inverse the same way. You can draw a little triangle and you can figure out the sides, and then you can figure out what it is. Instead, you can memorize them. So I'm going to show you them on the next slide. Okay, so here are all the derivatives of the various inverse trig functions. So we can see that we just did this first one. We did inverse sine, and it was equal to this. And in this case, the f of x is the inner function. So the one we just did had an inner function of just x. So the derivative of x is just 1. So we had 1 over the square root of 1 minus x squared. If there's a function that's anything besides x, where it has a derivative, we have to use the derivative of the function as well. So it's like the chain rule again. Okay, so here's all our different functions. You can pause the video to write them down if you need to. Something to note is that inverse functions are also called arcs. So for instance, instead of saying sine with the -1 as like the little power, instead of saying inverse sine that way, this could also be written as arc sine. Okay, so we're going to see both things, so just be familiar with it. So here we have arc cosecant, arc cosine, arc secant, arc tan, arc cotan. Okay, so let's look at this problem. Find the derivative of y equals 1 over the inverse sine of x. Okay, so first thing, I don't like having this in the bottom, so I'm going to rewrite this as the inverse sine of x to the negative 1, right? Because it's 1 over that, so that means that my exponent was a negative. That's why it's in the bottom. So now to find the derivative, dy over dx, I'm going to use the power rule with the chain rule. So I'm going to have negative 1 inverse sine of x to the negative 2. So I was using the power rule. But now what's inside, the inverse sine of x, has a derivative, and that derivative is 1 over the square root of 1 minus x squared. So again, we got that from, we proved it with the triangles, or you can go back to the previous slide and look to see what the inverse sine is. The x, the derivative is just 1, so that's why we have a 1 on the top. So if I just smushed it all together, I get negative 1 over, since this is to the negative 2, I'm just going to put it back in the bottom. So I'm going to say this is inverse sine of x squared times the square root of 1 minus x squared. Okay, so let's look at another example here. So here it's written as arctan, but it's the same thing as the inverse tan. So if I look at this, I have the arctan is the outer function, and my inner function is the square root of x. So I'm going to find the derivative. I'll just do f prime since it's f, sorry. So f prime of x is equal to, so I'm going to write over here. So my function, right, is square root of x, which is the same thing as x to the 1/2. So this is like, I'm just going to put f of x, not f of x, because the whole function's f of x. I'm just going to call this like y or whatever. So y equals that. So y prime would be 1/2 x to the negative 1/2. So when I'm writing this, you can do one of two things. You can write it as 1 over what the derivative is of the arctan times the derivative of the function, or just put the derivative of the function on the top. So again, I'm just going to go over here for 1 second. So here we have arctan, so we're using this one, right? So the function in this case is our square root of x. The derivative of the function is on top, and then you have 1 plus whatever the function is squared on the bottom for arctan. So we have, I'm just going to write this as, so 1/2 x to the negative 1/2 is on the top. And then on the bottom, we have 1 plus the square root of x, putting parentheses in weird spots, squared. So we end up with, to simplify this a little bit, which I would do, we don't really need these parentheses. Sorry, I put extra parentheses in. I got a little parenthesis happy here. My bad. There we go. I would just kind of clean this up a little bit personally. So I would make the top, let's say like 1 over 2 square root of x over 1 plus, and then the square root of x squared, that's just x. So I can simplify that a little bit. And then I don't like complex fractions. So what I'm going to do is just bring the denominator of my numerator down to the bottom. So I'm just going to make this 1 over 2 root x times 1 plus x. And that, oops, is fully simplified. Okay, let's look at another one. So here we have the function x over 3. So the derivative of that, d over dx, would be 1/3. So when I go to find the derivative of f, the 2 that's in front, that's my constant. So when I have a constant, I can just kind of keep that there. And then I'm going to take the derivative of what's next to it. So arc cosine of x over 3. The derivative of the inner function is 1 over 3, so that's going to be on the top. And then arc cosine, we have negative, so I'm just going to make it negative up here. Square root of 1 minus 1/3 x, I'm just going to call it 1/3 x squared. So I, again, am going to kind of simplify this a little bit. I'm going to move this 3 to the bottom, right? So same thing as like the other way that we did this. So I'm going to keep the top 2 times negative 1. So I'm going to keep that like negative 2. Sorry, get rid of that. Negative 2 on the top, and I'm going to bring this 3 to the bottom. So I have 3 square root of 1 minus, so if I square the 1/3 x, I'm really going to get 1/9 x squared. So I'm just trying to get rid of my parentheses. And then I could leave it like this, but the 3 that I pulled out, if I put it back in, that means it had to be a 9 inside the square root, since the square root of 9 is 3. So I can put that back in. So I'm going to actually do that. So we have -2 over square root. So if I put the 3 back inside, it becomes a 9 on the inside. So I really have like 9 times 1. So that's going to be 9. And then I have the 9 times -1/9 x squared. So that's just going to be minus x squared. So the whole point, I guess, of why I would put in the 3 inside is so I don't have a fraction under the radical. Most of the time, you don't really see fractions under radicals. So in order to kind of get rid of that fraction, you can multiply everything inside by 9, which means you're taking the 3 on the outside and bringing it in. So it's just fully simplified in this case here. Okay. Okay, find the derivative of y equals 3 inverse sine of x. So y prime is equal to, that 3 is that constant, so we're just going to keep that alone on the outside. And then here the inner function is x, so the derivative of x is just 1. So we're going to have 1 over the square root of 1 minus x squared. Okay, technically you could leave that alone, but I'm going to smush it. So that was like a little bit easier one. Here's your derivative. Okay, so it's more of just being able to work with the derivatives of the inverse function. So you want to be able to remember what they are and then apply them correctly. That's not the same problem. Okay, and then this last one, we've got y prime. So the inner function is 3x squared. So if I wanted to find the derivative of 3x squared, I'm going to get 6x. So if the 4 is the constant, that can just be pulled outside. The derivative of the inverse cosine of 3x squared, the derivative of 3x squared we said was 6x over, and then the cosine is the square root, but it's negative, so I'm going to put the negative in front. 1 minus 3x squared squared. So again, I like to clean things up a little bit. So this is going to give me -24x on the top. And then on the bottom, I'm going to actually square the 3x squared. So I get 1 minus 9x to the 4th. There's our derivative.